Hi guys, this is Dr. Praful Dikshit. I'm back with another video on this very interesting and fascinating topic called odds ratios. I find it fascinating. Most people don't even think in terms of odds ratios, not at least in their daily lives. But I do because, as I told you earlier, it lets me evaluate my chances of success versus my chances of failure. So I consider both the aspects. People usually don't think in negative terms. They like to be more positive about things. So they want to always think about the success. But that's just me, and let's move ahead. In the last video, we introduced odds ratios and discussed two very important introductory examples. As you might remember, this example of Mr. Blue, the shot putter, and who had to throw a shot put a certain number of times to succeed in a trial. And this was one example, right? And another example was that of COVID. Okay, so this was a second example in which this was this village which was supposed to follow a social distancing protocol to avoid getting entirely affected by COVID, right? So these were the two examples in the last video, and in both these examples, as you might see, there were two important points, the two important touch points, in fact. One was an event wherein there were certain subjects who were exposed to certain exposure, and there were two conditions in the two. Of course, obviously, there were several outcomes, but more importantly, there were two conditions. Based on two conditions, there were two scenarios, and one scenario was that there was an exposure. Another scenario was no exposure. Exposure versus no exposure. So the chances of success of the event versus the chances of failure of the event were evaluated in both the scenarios, in both the examples, right? That was the common point. And odds ratios are the relative probabilities, or we can say the probability of a success versus the probability of a failure. And that's an odd. And when we consider that in terms of an exposure versus a non-exposure situation, that is, we compare both the odds, okay, in order to get an idea of the efficacy of that exposure or the effect of that exposure. We can say if the exposure is, say, for example, a drug, a life-saving drug, it's some kind of an intervention into a disease, then we say it's a good effect. And if the disease is something like that, an exposure to a virus or something, in that case we say that it's a harmful effect. So in both cases it's an exposure. It can be a good exposure, it can be a bad exposure, but whichever way it is, the exposure has two outcomes or two scenarios. So there is either an exposure or there's no exposure. And when we have to measure the efficacy of the exposure, that is when odds ratios come in. And odds ratios basically measure the odds of the outcomes in the case of an exposure versus the odds of the outcome in case of a non-exposure of any event. So we have this important input from the previous video. But what next? How do we actually use this information to operationalize or actually apply this knowledge to get some results? In order to do that, we have to, actually dig a little deeper, go into the background and the associated concepts. But before we actually even go into those associated concepts or the background of odds ratios, whatever we have learned in the last video, it was kind of a superficial explanation of how odds ratios might work. There are some certain pertinent questions that arise when we actually go ahead and use odds ratios. Because, for example, some people might say, why do we even bother about odds ratios? Why do we even consider odds ratios? We can just think in terms of probabilities. Why odds? So all these questions at some point or the other are faced by researchers, academics, and even common people when they see such measures in, say, for example, magazines or newspapers and journals which cite research articles. So let me just explain this with a more basic example, and let me start with an illustration which I call Let's Dig Deeper Illustration Part 1. So now what do we have here? It's a series of A's and B's. Okay, I think most of you might remember in school, in primary school, the word problem of odd one out. Okay, so odd one out. The word odd rings a bell. Odd one out, odds ratios. Well, in this particular example right here, we have A's and B's. So no prizes for guessing which is an odd one out. I mean, we can't even say it's an odd one out, but it is odd, right? So B looks odd. It looks odd. It is odd because it is rare, right? Even among these, 10 instances of these letters out here, B is odd, right? We are already thinking in terms of odds, and if you're not, then let me ask you a question. What if these A's and B's were actually grades on a school term test or a series of tests? So every A represents a test score, right? So around the year suppose there are 10 tests, and A, B, A, B, A. This is the pattern of test results on your school tests. So now would you be concerned about the B's or only A's? Let me tell you, A represents a success, whereas B represents fail or failure. Okay, let's just think about it now. Is A the only important thing in this series, or B is also important? So would you want to think about B as well as A, or just A's? So I think the question has been answered, but then we need to move ahead and apply this particular knowledge into our understanding of odds ratios. So the odds are the probabilities of success versus the probabilities of failure. Okay. Now, why would actually be concerned about failure? You know, failure. So I strongly believe that we would definitely be concerned about failure in this case because it represents a test score which we are about to encounter, right? We're about to give a test, and there is a possibility of failure, and we would definitely be concerned about failure in a test. So this is one example of why would we even bother about a counter possibility of something. So failure is counter possibility of success, and we are definitely in this particular case bothered about failure. And well, let me just highlight this for you. Okay, so that's better. So A is a success, B is a failure, right? But more importantly, I mean, that's the intuitive part, but let's try and reason this. Why would actually be concerned about failure? It is because usually we do not have all the information beforehand. We don't know about whether we'll be successful or whether we'll fail on the test. So we have to go through evaluations, right? And for example, the test in this case, or the trials in case of academic evaluations. So this is why, since we don't have information and there is uncertainty, so in order to minimize that uncertainty, we would be concerned and we would think about how we can determine or at least estimate the outcome of the test, right? So when we are concerned about the outcome of the test, It can either be a success or a failure. We will definitely compare A with B. Now, A versus B is actually odds of success in that particular test. So we can actually go ahead and calculate the probabilities of the success and the probability of failure in this case. As you can see, this scenario right here, I mean this graphic right here, in contrast to this one, this original one, represents the probability of A's, or the probability of success, and this represents the opposite, that is the probability of failure. So let's see. There are total 10 outcomes. Out of 10, there are 8 possible or probable successes. So the probability of A in this case is equal to 8 divided by 10, which is equal to 4 by 5. Okay, and very simply, the probability of B in this case is equal to 2 by 10, which is equal to 1 by 5, right? Okay, now what are odds? So in this case, we can also calculate the odds. Now, we can calculate the odds of success. How do we do that? So the odds would be the probability of success divided by the probability of failure, that is B, or the odds of success. And the students who are not that good at studies might concern themselves more with the probability of B, right? That is the probability of failure. But average students would be concerned with both, so, and which is the case with most of the students. But in any case, most of the students would be concerned with the probability of failure, right? So we have to consider the odds of, now what the odds of failure here? Odds of failure, okay? Odds of failure is equal to the probability of B divided by the probability of A, okay, which is equal to 1 by 5 divided by 4 by 5 is equal to 1 by 4. So the odds of failure, in this case, the odds of failure is equal to 1:4. Conversely, the odds of success, which is usually the default odd, is 4:1. Okay, so now this preceding example gave us a very good peek into the practical value of odds, and why should we even bother to think about odds and think in terms of odds rather than just probability. But what about odds ratios? Because remember, that is the main topic here. So in order to appreciate odds, we need to move ahead, and we need to move to something which is the next topic, which is the background and associated concepts. Now, these background and associated concepts are a preceding step for us to develop a definition of odds ratios, because that is where we actually will be able to develop sufficient knowledge for applying that our research and professional examples, right? So in order to transition from the concept of probability to odds, and from odds to odds ratios, we need to essentially understand the concept of conditional probability. And to appreciate the concept of conditional probability, we need to understand, revisit probability a bit conceptually. Okay, so probability is the ratio of the occurrences of an event to the total number of possible occurrences, wherein we can express it as PA, a probability of A, which is the number of favorable outcomes divided by the number of total events in the sample space, or we can express it as NA divided by NS. So for example, the probability of Ajay eating samosa, Ajay Devgan, eating a samosa during a day may be a ratio of the number of times he ate samosas in a day to the total number of meals on an average. Okay, so we can express this as say P samosa, okay, P samosas equal to N samosas, okay, divided by N meals. Okay, so let's say Ajay eats 2 samosas on a random day, and assuming he eats only one at a time, and he eats 4 times a day in total. So we can express his probability of eating samosas as P samosas equal to 2 by 4, okay, which is equal to 0.5. So that was an example of a simple probability. Now, what on earth is conditional probability? So, well, conditional probability is the probability of an event A occurring given the probability of B occurring, wherein B can be treated as an exposure. So we can express this as conditional P A given B equal to P A intersection B divided by P B, or P the probability of A intersection B, or probability of A and B, which is equal to the probability of A given B multiplied by the probability of B. That's the mathematical notation for conditional probability. So now let's see how this works in this samosa, the Ajay's example. So on a random day, let's say the probability of Ajay eating a samosa while also eating a pastry, right? Samosa with a pastry is 0.3, whereas the probability of his eating a pastry is 0.4. So how do we differentiate between this probability of his eating a pastry and his eating a pastry given that he also eats a samosa on a given day? So we can express this as P samosa given pastry is equal to 0.3. Okay, that's the conditional probability. And a normal probability of his eating a pastry on a random day is equal to 0.4. Therefore, the probability of the combined probability of his eating a samosa and pastry can be expressed as the samosa and pastry, which is equal to the probability of samosa, I'm already hungry, samosa, given that he also eats a pastry, multiplied by the probability of eating pastry only. Okay, right. So that we can calculate that from this example. That's an example of how a conditional probability works. This isn't exactly applied in the concept of odds ratios, but since odds ratios and odds are about conditional outcomes, so to say, so it was definitely important. And in fact, an associated concept called let's see here, this next concept, an associated concept of odds ratios, is relative risk, and which is actually very important for us to understand and appreciate, because it has conditional probability as one of its bases. So relative risk and odds ratios both apply the principle of conditional probability, and you'll see how. So in order to illustrate how this conditionality works in the concept of odds and odds ratios, let's come back to the example of test scores, right? So wherein we had A's and B's as respectively the success and failure outcomes of tests. Okay, so let's assume that the one who is giving the test is, let's name it him, Mr. X. So let's say let's suppose that there's a scenario, okay, or a condition wherein Mr. X goes for extra classes, okay? And let's say while he goes for extra classes, he performs well on his tests, and this is the outcome of his test scores during the year. Okay. There's another scenario wherein he probably, there could be another scenario. Let's imagine he does not go for extra classes. Okay. Well, in this case, let's say his scores could be something like maybe an A and a B, and again an A and a B, and maybe two A's and a B and an A, and then again B and an A. And let me just highlight these B's as red. Okay. Red. Okay. Okay. Right. And okay, here we are. So the odds ratio of B, given he goes for extra classes, can be calculated. So the odds ratio of B, or the failure of Mr. X, in the tests, given he goes for extra classes can be calculated as follows. Okay, we can see here these are the odds if you consider B as the prime outcome. So these are the odds of B, right? And in case he goes for extra classes, this scenario right here is representative of when he goes for extra classes, right? And this outcome here is the represents when he does not go for extra classes. So these are the odds of Mr. X's results, or the failure results, when he goes for extra classes, and these are the odds of his failure results when he does not go for the extra classes. As we've seen from the preceding calculations, these odds we calculated as 1 by 4, and these odds right here we can easily see these are 2 by 3, which actually comes to 3 by 8. If we solve for this, that's the value we get. So let me show you how we arrived at this value in notational terms through a usual algebraic example. Let me just break it down into the odds calculations, and then based on that we derive the odds ratio. So odds of let's say odds of B, or failure when Mr. X goes for extra classes is equal to the probability of B divided the probability of A, which is equal to 2 by 10 versus 8 by 10. Okay, and So the odds would be actually 2 by 10 divided by 8 by 10, and that comes to 1 by 4, right? And then we have the odds of failure. Odds of failure, or B, when he does not go for extra classes. Okay, so we have the probability of B divided by the probability of A is equal to 4 by 10 versus 6 by 10. Okay, and that comes to 4 by 10 divided by 6 divided by 10, and that's equal to 4 by 6, or 2 by 3. So the odds ratio actually would be equal to 1 by 4 from here divided by 2 by 3 from here, and that would be equal to 3 by 8, right? Yeah, so in this video we learned how to operationalize the concept of odds ratios, and we also learned how to actually establish a practical value of odds and odds ratios, and why should we even bother about odds and consequently odds ratios versus probability in any situation. And then we know how to arrive at a definition towards, we are moving towards arriving at a definition to apply all this knowledge to practical and professional examples. We dug a little deeper, and through some practical examples we established the background concepts, the associated concepts of for example, probability, so to say, and conditional probability, which are essentially required in understanding and applying the concept of odds ratios. In the next video, we'll actually arrive at the definition of odds ratios, and from there on we'll move on to further applications of odds ratios. Okay, so that's it for now. If you really liked this video, do give it a thumbs up, and if you think it can be useful to others, do share it. And for more such videos, do subscribe to my channel, and do not forget to press the bell icon. So till the next time, thank you, take care, and have a great day.